Okay, today we're going to take a look at the law of sines. This is very handy for when you are trying to solve a triangle that is not a right triangle. Alright, obviously if we have a right triangle you can use Pythagorean theorem. But in a lot of cases we have other such triangles like an angle side angle or a side angle angle or a side side angle. These triangles we need to be able to have a way to solve for the missing parts that uses something other than the Pythagorean theorem. Alright, now in these types of triangles, your angle side angle and your side angle angle triangle, these two are going to work very, very nicely with the law of sines, and they're pretty much just going to be what I'm going to call straightforward cases. Alright, you're not going to have to do a lot of work to it. It's going to work out nicely, and you will be able to solve for all your missing parts of the triangle. The side-side angle triangle is what I call a special case. That's going to involve a little bit more work. Alright, and you're going to have to make some decisions and some thinking about the triangle, what's actually going on. And when we get to that one, that'll probably be close to my last one, we'll actually go through the different triangles and see what's happening. In general, my law of sines usually is given by this formula right here. It's the sine of angle A over side A is equal to the sine of angle B over side B, equal to the sine of angle C over side C. Note the capital letters for my angles, the lowercase letters for the sides. Alright, and I just drew an arbitrary triangle here to represent where your A's and B's and C's are located. Your capital letters are at the vertices because they're representing the angles, and the side opposite of an angle is the lowercase letter of whatever that vertex is. So if this is angle A over here, the opposite side is lowercase a. So that's how your triangles are basically going to be set up when using this. Okay, so for our first example, I want to take a look at a straightforward case. Okay, that's going to be the easiest to go through, where I got everything written out here, and it shouldn't take us too long to go through this one. Alright, let's suppose that they give you three pieces of information. Angle A is 40 degrees, angle B is 60 degrees, and side A is 4. You have to find all of the other missing parts. Okay, sometimes they will give you a triangle that's been drawn and place the information on there. Sometimes they will just give you the information in a line like that. You could draw your own picture if you wanted. Generally, if I sketch a triangle, I do not attempt to worry about drawing it to scale because it's not really important. It just gives you a visual about where your angles are in relationship to your sides. So I would be needing to find side B, I would need to find side C, and I would need to find angle C. Now, lots of different ways you could go about doing this. I think to start with, just from basic geometry in an early geometry class, you should remember that the three angles in a triangle add up to 180. So you could find angle C really easy. Okay, so let's even identify what we're doing here. Let's put find third angle. Okay, I'm going to find my third angle by adding those two numbers up. So I've got 60 plus 40, that's going to give me 100, and I know all three of them have to add to 180, so I'm going to take 180 minus 100, and that's going to give me 80 degrees. So I know angle C has to be 80 degrees. Alright, I'm going to make a list over here from everything that I am finding. Angle C has to be 80 degrees. Alright, another way you could do this is you could go ahead and add it to your diagram. That might be helpful if you're using the picture to try to figure out what needs to be over what. Okay, at this point, I'm going to use that law of sines, and I'm going to write a proportion on the things that I'm giving. I have been given angle A and side A, so I know that has to be included in my law of sines because I can only have one missing value when I'm trying to find something. Alright, so let's just start with B and say we're going to try to find side B. Okay, so find side B. Okay, so I'm going to set my formula up. Sine of A, so sine of 40 degrees, over the side opposite, which is a 4, is equal to the sine of 60, because that's the angle that I'm trying to find, or the side, and it's across from that angle, sine of 60 degrees, and over little b, and that's what I don't know. Alright, now, what I would do is probably before I grabbed a calculator, I would do a little bit of solving. I would go ahead and solve for b and then put that entire expression into the calculator. So I would cross multiply down because this is a proportion. So 4 sine of 60 degrees is equal to, I'm going to put the b in front, b times the sine of 40 degrees. Alright, so that is a multiplication right there, so I need to solve for b, so I'm going to divide both sides by the sine of 40 and divide by the sine of 40. Alright, at that point you have a nice little expression here. You can put this in your calculator and it will return a great big long value. Okay, you could even store that value, keep it, use it later if you wanted, and chances are the directions are going to tell you what to round to. Once this is plugged into a calculator, I'm going to go out 2 places. B is going to be approximately 5.39. If you've got a calculator handy, you might want to pause the video and go ahead and plug that in and see if you can get that value for side B. And do make sure your calculator is in radian mode, degree mode, because this is 60 degrees, this is 40 degrees, so check that on your calculator so you get the right value there. Now I'm going to go ahead and add it over here. This side has to be 5.39 right there. And then let's add it to our list over here. Side B is 5.39. Okay, now looking at the triangle, the only thing I have left here is going to be side B, so I'm going to find side B, C. Alright, so again, this is a rounded value. Alright, this angle B and side B here, this side B is a rounded value. Now, you could go ahead and use it. Even if you store it in your calculator, though, this is a number that would have went on forever and ever and ever, probably. Alright, so I'm going to try to avoid using this in future calculations because you do not want to round in the middle of the problem because that's going to throw your answers off. So I'm going to, again, come back here and stick with this sine of 40 over 4 because those are 2 values that were given, neither of which have been rounded. So I'm going to do sine of 40 degrees over 4. This time I need to find C, side C, so I'm going to use angle C as sine of 80 degrees over little c, because that's what I'm trying to find here. Again, cross multiply down. 4 times the sine of 80 degrees is equal to C times that sine of 40, dividing both sides by the sine of 40. Then I have an expression that I can enter into the calculator. Okay, so that expression right there, you can completely enter that in, and C then is going to be approximately 6.13 once you round that. So I could add that to my triangle over here, 6.13. Last value, lowercase c, is equal to 6.13. Alright, so in every time you do one of these, you're probably going to have the three missing values that they don't give you that you're going to need to find. Alright, so that was a straightforward example. Alright, and I don't think we need to do multiple ones of that. So let's take a look at what's going to happen if we do an example of one of the side-side angle triangles. Alright, this would be our special cases. Okay, so let's identify special cases. And this would be a side-side angle. Okay, now I'm not going to actually use a ruler or a protractor to draw these out, but we're going to assume that I'm going to pretend like I am drawing these to scale. Alright, in this case, you're going to be given 2 sides and an angle. Okay, so let's say they give you a specific value for angle A. So you've got a horizontal line that you're going to randomly start at. You would measure up at whatever that angle was. Alright, so measure it up at that angle. Now let's say one of the sides, alright, maybe a side B, and you measured it perfectly to what length it was supposed to be. You could run into a case where that other side that they give you, when you actually would measure it and come down, it would not be long enough to touch this other side, so in which case you would not have a triangle. Alright, it would not form because the dimensions just weren't right. So in this scenario we would have no triangle whatsoever. Okay, now another possibility of something that could occur you could be given an angle A. So you start with a horizontal line. You measure up precisely at whatever that angle A is. All right, one of the sides that they give you, you measure perfectly to however long that is. That would be the first side they give you. And then they could give you the exact length that you need, that when you drop that down, that it would actually form a triangle with three sides. This would be side A. In which case, you're going to have one triangle. You're going to have one triangle that you can form. Now, a third possible case, alright, let's say again they give you an angle A. You start with a horizontal. You measure precisely up to whatever that angle is. So that's my angle A. When you are drawing this side then, you are going to make it match one of those two sides precisely in your drawing. Let's go up a little bit higher just so I've got some room to play here. Okay, now, the third possibility here is that other side might be too long. So if you attempted to draw it like straight down, that's not going to work. Okay, so you would have to come up with something else you could do it. Well, if I angled it this way, I might be able to find the exact amount right there that would work, in which case it would be an obtuse triangle that would be formed. Or if I didn't move it to the left, I could move it to the right, exactly what I needed it to be, so that it would be the right length, in which case I would have formed an acute triangle. So in this scenario, you get two different triangles. Okay? Now, in a physics class where you're actually playing with this law of sines and there's practical application, you're probably not going to have, the no triangle or two triangles, because it's going to be connected to a real world situation. But in a math class, we are going to encounter these because we are just manipulating triangles, and we're trying to find what kind of triangles that we have. Okay, so this is your special cases here. Alright, and I just wanted to take an in-depth look at that before we actually worked one out. Now, for our first example, we're going to do a couple of these special cases. Let's suppose they give you A equal 2, little c equals 1, and angle C is equal to 50 degrees. Okay, and like I said, if you wanted, you could draw a triangle, but then again, you really don't need to draw a triangle. You've got angle C, you've got the side across from that, and then you've got one other side. Okay, so we have a side-side angle here going on. Alright, I know I have to use, when I set my proportion up, I have to use angle C and side C for my first, and then I'm going to go and work on trying to find sine of A there. So, let's write our proportion. Sine of 50 degrees over side C, which is 1. And then I'm going to do sine of A, because I'm looking for angle A, over the side A. Okay, again, got to cross multiply down here. So sine A times 1 is going to give me sine A. And then cross multiplying this way, 2 times the sine of 50 degrees. Alright, now this is going to give you a decimal, and again, it's going to be a great big long decimal. Okay, so what I would do at this point is kind of stop, think about what you're doing. You're trying to find angle A. Alright, so in other words, you're trying to go backwards. So this is the case where you're going to need to use the inverse sine button on your calculator. Alright, and I don't want to round this at all, so I'm going to leave it. When I put it in the calculator, I'm going to enter it 2 sine of 50. So angle A is going to be equal to the inverse sine of 2 times sine of 50 degrees. Okay, now as soon as you do that, something unusual is going to happen. You probably definitely need to pause the video and try this on your calculator. Alright, you should end up with an error. It might say math error, it's going to be an error. Okay, in which case that means there is no angle A. Alright, and if there's no angle A exists, alright, in which case when we look at this value right here, no angle A exists for any sine value that's greater than 1. So you're guaranteed it's not going to exist. If I don't have an angle A, I don't have a triangle. So from this, as soon as you do this and you get an error in your calculator, you can automatically conclude, therefore, there is no triangle with the given measurements. Okay, so this is one of those special cases. Alright, and that's when you're going to encounter is when you get that error on your calculator. Alright, now if we take a look at another special case, okay, let's say we have maybe say side A is 3, side B is 2, and angle A is 40 degrees. Okay, so here again, I've got a side-side angle. Alright, so I might be thinking ahead of time, hey, I could run into a problem with this, could be one of these special cases. Alright, you're not necessarily going to know what's going to happen until you just start playing with these numbers and see what happens. Alright, so I'm going to set up my first proportion. I'm going to use sine A over A because I have two of the same values there. So I'm going to do sine of 40 degrees over 3 equals, I'm given side B, so I want to find the angle, so sine of B all over 2. Okay, going to cross multiply down. 3 times the sine of B is going to be equal to 2 sine of 40 degrees. Alright, again, I'm not going to grab my calculator just quite yet. I'm going to go ahead and divide both sides by 3. Sine of B is equal to 2 sine 40 degrees over 3. Alright, and again, this is one of those where I'm trying to find my angle, so I'm going to use that inverse button on the calculator. So my B is going to be equal to the inverse of sine of 2 sine 40 degrees all over 3. And if you can get it plugged in the calculator like that, that's really nice. You won't be tempted to round any values whatsoever, and that's good. Alright, now, the calculator itself is going to return a value of B is approximately equal to 25 degrees. Alright, if you watched the video where I discussed inverse trig functions and using that inverse trig button on your calculator, then hopefully you remember that that's not the only value that has this sine value. Okay, and I would highly recommend watching that video if you haven't yet. But basically, a really easy way to find the other angle without actually using a unit circle or trying to do that type of manipulation is you can take 180 minus the angle that you've got, and that gives you 155 degrees. Alright, so 155 degrees is a second possibility for another angle, because if I did the inverse sine of this, I get 25, and there's another spot on that unit circle, another spot around the circle that will give me that exact same value. Now, at this point, this should tell you you have two possible triangles. Alright, so there's two possible triangles. So now you've got to do a little bit of thinking and that sort of thing to make a judgment call on which one's going to work. You know, do I really have two, or is it just trying to fool me here? If I take 25 plus 40, alright, then that's something less than 180, and so that's going to tell me, oh, that could be a possible triangle. If I take this 155 and I add 40, well, I get 195. Alright, in those two angles alone, you're over 180. So, yes, this was a possibility, but I can rule it out because I know what angle A is, and if angle A is 40, I cannot have an angle B at 155. Okay, now, sometimes they're both going to fit, and you're going to end up with two triangles, of which you'll have to find twice the amount of stuff. Okay, so there I have tested that. Okay, so now I know it's 25. I can real easily find that third angle. Alright, so let's find third angle. So add up the two that I've got there. So 40 plus 25, that's going to give me a 65. I know there's 180 degrees in every triangle. 180 minus 65 is going to give me 115 degrees. Okay, so let's start us a list right here in the middle. So that means that we found angle B at 25 degrees from over here. Angle C is 115 degrees, and then the only other remaining value would be little c, side C. So that's the one we'll find last. So find side C. Kind of drew that kind of big. This is side C. Alright, so again, we want to use values that we know are accurate and have not been rounded. So I definitely want to use side A and angle A. So I'm going to do sine of 40 degrees over 3 equals, and then sine of 115, because that's angle C right there, over little c. Okay, cross multiplying, down, 3 times the sine of 115 is equal to, I'm going to go ahead and put the c in front, c times the sine of 40 degrees. Alright, solving for c before I grab that calculator. Divide by the sine of 40 degrees. Divide by the sine of 40 degrees. Alright, and then putting this in your calculator, hopefully you're going to return a value of c being approximately 4.23. Alright, so there's my final side. You definitely want to pause the video at the various parts of this and make sure that you are able to use your individual calculator to get these values. Alright, now without actually working through an entire another example, alright, let's just take this as a possibility. If I would have had a side-side angle, and when I did the inverse sine, I get two possibilities. Alright, had they both been small enough so that when I took this value and 40, something like 65 on this, then I knew that would form one triangle. And if this was, I don't know, say some other value, small, like maybe one, you know, like just say maybe 65, 65 and 45 would be 105, I'd be under 180, so this also would form a triangle. Alright, so in which case, if both of these values would have worked, I would have had that third scenario right there where I had two triangles. And you would literally have to work out one set, you'd have one set of answers, and then you would do it again, and you would have a second set of answers for that second triangle. Alright, so law of sines really is, once you get the hang of placing things and writing that proportion, the math of it is not too bad. Solving proportions, using a little bit of calculator work to get those values. Definitely thanks for watching. If you liked the video, go ahead and give me a thumbs up. Be sure and share with your friends, and leave a comment because I'd like to chat with you. Thanks.